This is your Hooke's Law activity calculations video. It's not a lot of calculations. Your notebook should have these diagrams in them, and you have the table. The only thing we're measuring, this is fake data by the way, there's no way we have a spring in this school that goes 14.3 meters, but I picked a number so I could demonstrate how to calculate stuff. This is the only thing you measure. We're going to calculate the K, the work in the spring, and the potential energy in the spring, and this is a simple calculation to calculate the force that's on the spring. So you hang a weight, and from the weight I multiply that by 10. I multiply the mass by 10 to get my newtons, which I'm sure we know how to do. Then to find the K, the spring is stationary, so I know the force on the spring is equal to the force of the weight, which is this, so that goes on top. I just solved for this equation right here. The force of the spring, Hooke's law, is equal to K times delta X, so you solve for the K and you plug the numbers in, and that's my K. Also have a formula for the same formula for the work on the spring, and the potential energy is the same, so once I find the work in the spring I can just put that answer over here in the potential energy. And I just plugged in the 1/2 K delta X squared, and you can see that and follow along. Now the instructions also said to do a couple of other things. I plug in your data in your calculator, so this data will be my y-axis because this is y equals mx, right? So this is my y-axis, my delta x is my x-axis, and I generate a linear equation, and the slope of that should be my K. So I just made up that this is what I got. We can ignore the y-intercept. If you had ideal data, it would be 0 anyway. So on number 7, problem 7, I give you an unknown weight, so I hung that weight on the spring, and it stretched 28 meters. It's a long spring. Okay, again, this is fake data. But I would use this equation right here, ignoring the y-intercept. I use Hooke's law using this for my K, and I just plug it in, and f of s equals K delta X, so that would mean it was 8.68 newtons, and I divide that by 10 to find my mass. I stick this on a scale. My scale reading is 0.92, and you see I forgot to do this when the first time I did it. This is a percentage error. We're going to assume the scale reading is correct. So this is an error. So I'm going to take the difference in the two measurements, divide by the scale reading, times 100. In my case, I got 5.4%. The next thing we want to do, we're going to predict how far a 2.4 kilogram weight mass will stretch the scale. Stretch the spring, sorry. So I find the force on the spring. I just multiply 2.4 by 10. I get 24. I plug in my numbers for this equation, so I put my 24 for my force. This again comes from the slope of the line from the calculator. I predict that my delta X in my case is 77.4 meters. That's not realistic, obviously. And then I hung that weight on there, and I actually had 79.7. Again, this is a percentage error because this is how we should be able to measure this really closely. So we know what the right answer is. It's 79.7. So my percentage error is the difference divided by my 79.7, and that's my percent error. And then you just do the worksheet. Congrats. Good luck.